All right, so over the past couple days, we have done 2 labs so far. We did a bouncy collision, then we did a little explosion. Today we're going to do a sticky collision. All right, now. I'm going to draw here, then I'm going to demonstrate, then you're going to do it. Okay? So, what?
We weren't supposed to draw.
No, I had to start again.
Are you going to draw the same thing?
I'm literally going to draw the same.
Okay, I'm not going to cross out.
And maybe more because I must have looked up crowding out 3 times.
I know.
And then
Was that money supply or was it?
All right. So, watch please.
I still don't.
crowding out. No, it causes investment.
If you can't see these cards,
The government, right?
Oh my goodness, it's sticky. Is it Velcro?
it's a magnet. If you can't see the cards from where you are, please move yourself so that you can see them. Okay? So I have a card with a mass on it, and I'm going to send it in here. It's going to hit and stick to this other card. Okay? It's going to hit and stick.
That's so cool.
Did you see it happen? Okay, now without the thing in it, it's a little easier to notice what's happening here. What happens? How does the speed of them together compare with the speed of the one originally? Is it a little slower?
Yeah.
Yeah, it is, and it might depend on like how much. Where are you going? Do you notice it slow down?
Yeah, but it's
Okay. So it really depends on, it might depend on how much stuff there is in the cart, right? It might depend on how much stuff is in the cart, but we're going to diagram it up and you guys are going to make the same type of measurements as you did last time. So we have this cart with some stuff on it. It's moving to the right. It's going to hit a car that is less massive at rest. The actual masses of these cars don't matter. I'm just trying to make it so that it's doable for you guys. And in fact, you could take this one and send it back at this one if you wanted. But let's just do it like this. That way we can all get something similar. What we noticed is they hit and stick together. Okay? They hit and stick together, and what did you notice about the speed? A little bit slower?
Slow down.
Okay? Now, to me, this actually makes some sense because when the heavy car hits the light car, does it push it forward? It does. That's why in the after picture, the light car is moving forward. But if the heavy pushes on the light to the right, what's the Newton's third law force pair there? They are equal, right? That means the light one pushes the heavy one back, which slows it down. Is that cool? So let's look at the position time graph and the velocity time graph for each of these. All right. Now, the sensor is over here, so this car is moving away from the sensor. So it's moving away kind of fast. It's still moving away, but it's less steep. What does that mean about the speed? It's slower, that's right. So during the collision, it definitely slows down. What's wrong? You can't see?
Oh, is that a V? Okay.
Yeah.
Is that X or Y?
Yeah.
It's
X.
on the Y.
So this is the position time graph, so it's an X, and that's the velocity time graph, so it's a V. So what's happening here is that this car is moving away from the sensor with some speed. And then it hits and it slows down. So the speed decreases. Does that seem reasonable for you? All right. The red one's a little bit harder to interpret. Okay? The red one's a little bit harder to interpret. The problem is, for the red one is, the sensor that's seeing its motion is on that side of it. So the red one, originally it's at rest. And then it starts moving. The problem is, it's moving toward the sensor, so the sensor thinks its velocity is negative because it's moving toward the sensor. So your graph will look like this. Okay? Your graph will look like this, which is fine. It just it's problematic, and I'll show you why it's problematic. Over here, it's not moving, so the velocity is 0, and then it speeds up. But it speeds up in the negative direction according to the sensor. But which way is it actually moving? It's still moving to the right. So all velocities are going to be positive today, even though when you read this, it's going to be negative, but that's because the sensor sees it moving toward it. This may not make sense to you in this moment, but when you're back there and you're like, why is this velocity negative? Hopefully you'll remember this moment. We need all velocities positive today because all cars are always going to be moving to the right. Cool? So what we're going to do is we're going to fill out the same chart. I love this chart. So we got M1, V1, P1, M2, V2, P2, and P total. This is before, after. When you go to analyze this, okay, you're going to need to remass your cars because I took the brackets and hoops off, so their masses are going to be different. So make sure you check their masses. This is the velocity 1 before. This is velocity 1 after. This is velocity 2 before, which is equal to 0, because that car is at rest. True? And then this would be velocity 2 after. Is that cool? You guys know what to do? All right, we got about, let's take about 15, maybe 20 minutes if you need them. I don't think you'll need 20, but let's have at it. 3, 2, 1, go.
Always goes.
Same groups as we've been working in.
Best